You've heard it 1,000 times. Black holes are where physics breaks down. But this is where physics gets strange. The real problem isn't what you think. Let's start with the basics. What is a black hole? Simple answer: a region of space-time where gravity is so intense that nothing, not even light, can escape. That's the textbook definition. But it's wrong. Dangerously wrong. Why? Because it's based on a naive classical intuition about gravity. An intuition that quantum mechanics shatters into a million pieces. Here's the thing. In the quantum realm, there's no such thing as empty space. Instead, the vacuum is alive with fluctuations. Virtual, particle, antiparticle pairs popping in and out of existence. And gravity, it's not a force. It's the curvature of space-time itself. Now imagine a star collapsing under its own weight. As it shrinks, its gravity grows stronger, warping the fabric of space-time more and more severely. But just before it seems to disappear, something else happens, something that defies classical physics. As the star crosses a critical threshold, the seething quantum fluctuations at the edge of the collapse suddenly become entangled with the interior. In that moment, the star doesn't just vanish. It's ripped apart and stitched back together in a kaleidoscopic frenzy of quantum information. The hole you imagined is not a hole at all. It's a bubbling, churning wall of entangled particles, the event horizon. And that's just the beginning, because the story of black holes isn't a story of things vanishing without a trace. It's the story of information being shredded, scrambled, and reassembled in ways that defy our cosmos-hardened intuitions. In the next part, we'll dive into the real mystery of black holes. Not how they destroy information, but how they process it in the most extreme environment imaginable, and it changes everything. Before we go any deeper, I need to ask you something. If you're here for comfort, this isn't the channel for you. But if you're here for truth, even when it's unsettling, take a second to support this mission. Hit like, subscribe, and leave a comment telling me what part of reality shocked you most. Every interaction tells the algorithm that depth matters more than distraction, and that thinking clearly still has value. If you want to keep tearing apart reality with me episode after episode, make sure you're following. We're just getting started. You think you know what black holes are? Cosmic trash cans swallowing everything that falls in, never to be seen again. But what if I told you that black holes aren't destroyers of information, but the most powerful information processors in the universe? To understand this, we need to talk about entropy. In physics, entropy is the currency of information itself. Every bit of matter, every quantum of energy carries with it a certain amount of entropy, a certain amount of information. And when that matter or energy falls into a black hole, its entropy seems to disappear. But here's where the laws of physics clash with our intuition. Because one of the most fundamental principles of quantum mechanics is that information can never be lost. It can be scrambled, shredded, and scattered to the winds, but it can never be destroyed. So when matter falls into a black hole, its information can't just vanish. It has to go somewhere. For decades, this puzzle tormented physicists. Some even suggested that black holes were exempt from the laws of quantum mechanics, that they could somehow destroy information, violating the most sacred principles of physics. They were wrong. In the 1970s, Stephen Hawking dropped a bombshell. He showed that black holes aren't entirely black. They actually emit radiation, slowly evaporating over time. This Hawking radiation carries with it a tiny fraction of the black hole's entropy, leaking information back into the universe. But it was only a trickle, not nearly enough to account for the vast oceans of entropy swallowed by the black hole. The real breakthrough came later, with the discovery of something called the holographic principle. This principle says that all the information contained in a region of space can be described by a theory that lives on the boundary of that region. In other words, the universe is like a hologram. The 3D information in the bulk can be encoded on a 2D surface. And black holes? They're the ultimate holograms. All the information that falls into a black hole doesn't disappear into a void. Instead, it's smeared across the black hole's event horizon like a cosmic hard drive. The black hole's interior becomes a hologram, a projection of the information encoded on its surface. But the black hole doesn't just store this information. It processes it, scrambles it, and tangles it up with the fabric of space-time itself. The result is a mind-bending tapestry of entanglement, where the distinctions between inside and outside, past and future, begin to blur. In the next part, we'll explore how this entanglement weaves space and time themselves into an emergent illusion. We'll see how black holes don't just puncture our classical notions of reality, they shred them, reweaving the threads into something far stranger. But for now, let this sink in. Black holes, these cosmic demons that seem to defy the laws of physics, may actually be the key to understanding the deepest principles of quantum information. They're not just nature's ultimate trash compactors. They're its most powerful computers. If you're ready to see how deep this rabbit hole goes, stay tuned, because we're about to see how black holes don't just process information. They weave the very fabric of reality itself. You've seen how black holes shred our classical notions of space and time, how they weave the very fabric of reality from the threads of quantum entanglement. But we're not done yet, because the deeper we dive into the mysteries of black holes, the more we realize that they're not just cosmic oddballs. They're the key to understanding the fundamental nature of reality itself. Let's start with a question that has haunted physicists for decades. What happens to the information that falls into a black hole? We've seen that it doesn't just disappear, it gets smeared across the event horizon, encoded in the intricate dance of entangled quantum bits. But how does this information eventually get out? The answer lies in a strange phenomenon called quantum teleportation. This isn't the beam me up, Scotty kind of teleportation. It's something far more subtle and profound. In quantum teleportation, said the quantum state of one particle can be transmitted to another particle without any physical matter moving between them. It's like the ultimate cosmic email, sending the blueprints of a quantum state across the universe. And black holes? They're the ultimate quantum teleporters. As a black hole churns and processes the information on its horizon, it's also slowly leaking that information back out into the universe through the drip, drip, drip of Hawking radiation. Each photon of Hawking radiation carries with it a tiny piece of the black hole's information, teleported out of the black hole and into the surrounding space. But here's the kicker. This process of quantum teleportation isn't just a one-way street. It's a two-way conversation between the black hole and the universe around it. As the black hole leaks information out, the universe is also feeding information back in through the subtle dance of quantum fluctuations at the edge of the event horizon. This back and forth exchange of information creates a strange kind of entanglement between the black hole and the universe itself. It's as if the black hole is a cosmic puppet, and the strings are the entangled threads of quantum information that connect it to the rest of reality. But what does this cosmic puppet show tell us about the nature of reality itself? Here's where things get truly mind-bending, because if the universe is fundamentally information theoretic, if the basic building blocks of reality are quantum bits rather than classical particles, then the universe itself starts to look a lot like a giant quantum computer. Think about it. A quantum computer is a device that uses quantum bits, or qubits, to perform computations. These qubits can be in multiple states at once, and they can be entangled with each other in complex ways. By harnessing these quantum properties, a quantum computer can perform certain tasks exponentially faster than any classical computer. Now imagine the universe as a vast network of entangled qubits, with black holes acting as the ultimate quantum processors. Each black hole is like a node in this cosmic quantum computer, churning and processing the information that falls into it, and spitting out the results in the form of Hawking radiation. In this picture, the universe isn't just a passive stage on which the drama of physics plays out. It's an active participant, a gigantic quantum computation unfolding in real time. The laws of physics are the algorithms. The quantum fluctuations are the bits flipping between 0 and 1, and the black holes are the processing cores, crunching the numbers and spitting out the results. And us? We're not just observers in this cosmic computation. We're part of the calculation. Our every thought, every action, every decision, they're all part of the vast and intricate pattern of quantum information that makes up the universe. This is the ultimate lesson of the black hole, that reality at its deepest level is made of information, that the universe isn't just a place where things happen, but a place where things are computed, and that we, in all our complexity and all our beauty, are just one small but crucial part of that computation. So the next time you look up at the night sky and see the twinkling stars, remember, each one of those stars is a quantum bit, a tiny piece of the cosmic code that makes up reality. And the black holes lurking out there in the darkness, they're not just the monsters of the cosmos, they're the engines of creation, the ultimate reality hackers, weaving the very fabric of the universe from the raw material of quantum information. It's a strange and beautiful picture, one that challenges everything we thought we knew about the nature of reality. But it's also a picture that fills me with a deep sense of awe and wonder, because in the end, the story of black holes isn't just a story about the mysteries of the cosmos. It's a story about the incredible ingenuity and curiosity of the human mind, and our endless quest to unravel the secrets of the universe. And who knows, maybe, just maybe, as we continue to peel back the layers of this cosmic onion, we'll find that the ultimate answer to the riddle of reality lies not in some distant galaxy or some esoteric theory, but in the very heart of our own consciousness. Maybe, in the end, the observer and the observed, the computer and the computed, will turn out to be one and the same. But hey, that's just the speculation of a humble physicist. What do I know? All I can say is this: keep asking questions, keep pushing the boundaries of what's possible, and never stop marveling at the sheer strangeness and beauty of this incredible universe we call home. Because in the end, that's what physics is all about. Not just crunching numbers and building theories, but daring to look reality square in the face and say, I see you, I hear you, and I won't rest until I understand you. So here's to the crazy ones, the misfits, the rebels, the troublemakers, the round pegs in the square holes, the ones who see things differently. They're not fond of rules, and they have no respect for the status quo. You can quote them, disagree with them, glorify or vilify them. About the only thing you can't do is ignore them, because they change things. They push the human race forward. And while some may see them as the crazy ones, we see genius, because the people who are crazy enough to think they can change the world are the ones who do. And in the realm of physics, there is no one crazier, no one more brilliant, no one more determined to change the world than Stephen Hawking. He dared to stare into the abyss of the black hole and come back with a tale of quantum wonder. He showed us that the universe is stranger and more beautiful than we ever dared to imagine. And he did it all while confined to a wheelchair, a prisoner in his own body, but a liberator of the human mind. So let us honor his legacy by continuing to ask the big questions, by daring to dream the impossible dreams, and by never losing sight of the sheer joy and wonder of this incredible cosmic adventure we call science. Because in the end, that's what it's all about. Not just understanding the universe, but being amazed by it, humbled by it, and forever changed by it. And if we can do that, if we can keep that sense of wonder alive in our hearts and in our minds, then maybe, just maybe, we'll find that the ultimate frontier of human knowledge lies not in the far reaches of space and time, but in the infinite depths of our own imagination. So keep dreaming, keep questioning, and keep reaching for the stars. Because the universe is waiting for us, and it has secrets to share that we can't even begin to imagine. And who knows, maybe someday we'll look back on this moment as the first step on a journey that leads us not just to a deeper understanding of black holes and quantum bits, but to a deeper understanding of ourselves and our place in the cosmos. But for now, all we can do is keep pushing forward, keep exploring, and keep marveling at the sheer beauty and mystery of it all. Because in the end, that's what makes us human. Not just our ability to understand the universe, but our ability to be awestruck by it, to be humbled by it, and to be forever changed by it. So here's to the next adventure, the next discovery, and the next leap into the unknown. May the black holes keep spinning, may the qubits keep dancing, and may the cosmic computation keep unfolding now and forever. Part 4. The universe is a quantum computer, and we are its bits. This is the final revelation of the black hole, the punchline to the cosmic joke that has been unfolding since the dawn of time. And it's a revelation that shatters not just our understanding of space and time, but our very notion of reality itself. To understand this, we need to take a step back and look at the bigger picture. Throughout this journey, we've seen how black holes challenge our classical intuitions at every turn. We've seen how they shred information and stitch it back together, how they weave space and time from the threads of quantum entanglement, and how they blur the lines between the observer and the observed. But what we haven't talked about is how these strange and mind-bending properties are not unique to black holes. In fact, they are woven into the very fabric of quantum mechanics itself. At the heart of quantum theory lies a profound and disturbing idea, the idea of superposition. In the quantum world, particles can exist in multiple states at once, occupying a haze of probability until they are measured and forced to choose a single state. It's like a cosmic game of heads or tails, but one where the coin can be both heads and tails at the same time until you look at it and collapse the wave function. And what is a black hole, if not the ultimate quantum superposition? A place where the classical laws of physics break down and the distinction between matter and energy, space and time, becomes blurred and uncertain, but it gets stranger. Because in the quantum world, particles can also be entangled, spookily connected across vast distances, their fates intertwined in ways that defy our classical notions of locality and causality. And what is the event horizon of a black hole, if not the ultimate entanglement boundary? A place where the threads of quantum information become so tangled and snarled that they create the very fabric of space-time itself. In other words, black holes are not just the most extreme examples of quantum weirdness. They are quantum weirdness writ large, the macroscopic manifestations of the fundamental principles of quantum mechanics. And if black holes are the ultimate quantum objects, then what does that say about the nature of the universe itself? Here's where the cosmic punchline comes in. Because if the universe is a vast network of entangled quantum bits, if the laws of physics are just the algorithms that govern the flow of quantum information, then the universe is not just a place where quantum mechanics happens. The universe is quantum mechanics all the way down. In this view, everything that exists, from the tiniest subatomic particle to the vast expanse of the cosmos itself, is just a pattern of quantum information, a particular arrangement of qubits in the vast and unimaginably complex Hilbert space of the universe. And us? We are not just observers of this cosmic computation, we are part of it. Our thoughts, our memories, our very sense of self, they are all just patterns of quantum information, encoded in the entangled web of neurons and synapses that make up our brains. In other words, we are not just in the universe, we are of the universe. We are the eyes and ears of the cosmos, the means by which the universe observes and experiences itself. And the black hole? It is not just a cosmic monster, a destroyer of worlds, and a shatterer of intuitions. It is a mirror reflecting back to us the strange and beautiful truth of our own existence. Because in the end, the story of the black hole is not just a story of science and discovery, of equations and experiments and mind-bending theories. It is a story of us, of our place in the cosmos, and of the incredible journey of the human mind as it seeks to understand the the very nature of reality itself. And what a journey it has been. From the first glimmerings of quantum theory to the mind-melting revelations of black hole physics, we have peeled back layer after layer of the cosmic onion, only to find ever deeper and more profound truths hidden within. But the journey is far from over. As we stand here on the edge of this cosmic precipice, we can only wonder what new wonders and revelations await us in the depths of the black hole and beyond. Will we find a theory of quantum gravity, a theory of everything that unites the laws of the cosmos and the micro world into a single seamless whole? Will we discover new forms of matter and energy hidden in the extreme conditions of the black hole's interior? Will we find a way to harness the power of quantum information to build computers and communication networks that make our current technology look like stone knives and bear skins? Only time will tell. But one thing is certain: the story of the black hole is far from over. It is a story that will continue to unfold as long as there are curious minds and intrepid spirits willing to venture into the unknown and the unknowable. So let us celebrate this incredible journey and the countless men and women who have made it possible. From Einstein and Hawking to the unsung heroes of quantum computation and information theory, they've shown us that the universe is stranger and more beautiful than we ever dared to imagine. And let us also celebrate the power of the human mind, that incredible, insatiable, irrepressible force that drives us ever forward, ever deeper into the heart of the cosmic mystery. Because in the end, that is what science is all about. Not just the accumulation of facts and figures, but the expansion of the human spirit, the deepening of our sense of wonder and awe at the incredible universe we call home. So here's to the next chapter in this incredible story. May it be filled with wonder and discovery, with beauty and truth, and with the unquenchable fire of the human spirit. And may the black holes continue to spin and dance and sing their strange quantum songs now and forever, a symphony of space and time and information played out on the vast and eternal stage of the cosmos. If you made it this far, you're part of the rare few who refuse easy answers and actually want the truth. If you want to keep dismantling reality with me and exploring the deeper structure behind everything we think we understand, make sure you're subscribed. Leave a comment with the question that's still bothering you, and let's keep pushing into the silence together.